In this lecture, we are going to answer one of the most common questions I get. That is, once we've trained the model, how do we save it for later use? For example, after training a model in Google Colab, I might want to copy that model into my production server so that other services in my company can make use of that model that I just trained. This lecture will show you how to save a model to a file and then load it back at a later time. In addition, we'll see how to download the saved model from Google Colab. First, note that this is a continuation of a notebook we were previously looking at. As usual, you can determine what notebook we are currently looking at using the title of the notebook. So if you left this notebook previously, you may want to reopen it at this point so you can follow along. Let's start with the central object that we need for this process, the stateDict. As you can tell by its name, it's a dictionary. If you look at what we get when we call model.stateDict, we can see that it's not just any dictionary, but rather an ordered dictionary. That kind of makes sense, since if you're iterating through the dictionary to populate the weights of a neural network, you would want to do that in the order that your model expects. As you can see, it's nothing but the parameters of the model. Since we just have one layer in our model, the first element is the weight matrix, and the second element is the bias vector. The next step is to save the model. We can accomplish that in just one line of code, torch.save. For the first argument, we pass in the model's stateDict, and for the second argument, we pass in a file path. I've just passed in mymodel.pt, so the file mymodel.pt will be saved to the current directory. You can see that after saving the model, when I do an ls, the file I just saved appears as expected. The next step is to load and evaluate the model to ensure that we saved it correctly. In order to do this, we first have to recreate the model the same way it was created originally. That might seem strange, since we still have to replicate the code we had earlier. This will probably make more sense to you once you've seen more complex models, which will involve defining our own classes. In those cases, you would just instantiate an object of that class, which is one line of code, which would be more compact than this. In any case, passing code around is very lightweight because code files are just text. Anyway, we'll call this model 2 so as not to interfere with our original model. Next, we call model2.loadStateDict and pass in the stateDict that we just saved. We get that by calling torch.load and passing in the file path where our model file is located. You can see that if your load is successful, it will say all keys match successfully. At this point, we would like to know, is our reloaded model the same as the model we saved? Luckily, this is an easy check, and we already know how to write this code. We just take our code from earlier to compute the accuracy of the model on the train set and test sets, but this time we'll use model 2 instead of the original model. As you can see, we get precisely the same accuracy as we did earlier. At this point, you might be wondering, so I just saved my model. It's in my local directory. But it's not my local directory, it's my Google Drive's local directory. What if my teammate asks me for this model? How can I share it? And that is the next question we are going to discuss. In fact, this is quite easy, and it's another reason I really like Colab. So over on the left here, you may have noticed this sidebar with some icons. If you click the folder icon, you'll see all the files in your current directory, including mymodel.pt, the model file we just saved. So let's right-click that. And now you can see that there's this option to download. And of course, that's how you can download this file to your local hard drive. Another option is to use Python code to download the file. Now, I've heard that this only works for Chrome, but of course that may change in the future. We can use the same module we used earlier for uploading files. So we import files from the google.colab module. Then we say files.download and pass in the file path. When we run this cell, the file is downloaded by our browser as usual. All right, so that works as expected.